Yeah, so let me go back. The session has ended. Okay, so we wrote our equation. So we had our equation, which was for this section. Okay, we had the first equation, which was what? Let me write that somewhere here. So we had the equation, which was tension, okay, minus what? M1G, okay, which is equals to acceleration was positive. So we had M1A. Then on the other side, we had T minus what? I think I omitted something. Let me just correct that. So M1 what? Sine of theta. Okay, M1J sine of theta is equals to what? Is equal to M1A. Then this side is T minus M2J. Okay, is equals to what? Acceleration is down, right? So equals to minus M2A. Okay. So we can either use substitution or you can use elimination to find your acceleration and the tension. I'm going to find acceleration for you. You have to find the tension by yourself. So that will be equation 1. This is your equation 1. Okay. And then we have equation 2. So by elimination, that will be equation 1 minus what? Equation 2. We shall have minus M1 G sine what? Sine theta. Okay. Plus M2 G equals to what? M1 A. Okay, M1A plus what? Plus M2A. Okay, yeah, fantastic. So once you have this, we need to make A the subject. So that will be, I'm going to rewrite and make the plus come first. Okay, so that will be M2G. Okay, minus what? Oh, better still, let me just do the factorization. Okay, at a go. So I'm rewriting and factorizing. That will be what? M2 minus what? M1 sine. Okay, sine theta. Okay, then I factorize G out. So that will be G here. Okay, is equals to, I'm factorizing A out. So that is M1 plus what? Plus M2. Okay, good. So if we divide both sides by M1 plus M2, okay, and do same for this side, which is M1 plus M2, okay, or M2 plus M1, okay, you're going to get your acceleration to be what? M2 minus M1 sine theta J over M1 plus M2. Okay, so your task will be to find the acceleration of the system. So I expect you to be finding all those ones I've asked you to find. Okay, you have to do that, and then I'll communicate on which platform to send that information to. Okay, so we got our acceleration. So these are the key areas we left out last week. Okay, we couldn't complete last week, but we had a lot. to do. Okay, so I'm clearing the screen. If there's any question, let me take just 2 questions, then we move on. If there's any question, send it as a chat, and then let's move on. If there's any question, you can send us a chat, then we'll move on. Okay. No, reaction acts in the y direction, vertical. Okay, but the motion is only in the x direction. When you are moving in the horizontal direction, your weights, the weight and the normal reaction, okay, do not count because they are all in what? Vertical. Okay. So the net acceleration in the vertical direction is what? 0. The motion is only in the x direction. Okay, any other question? Any other question? You can send your question by chat. Okay, let's move on then. Yeah. So moving on, I think this, yeah, we'll see this later too. But for now, let me just touch on it. So once we see this system here, okay, this is a ladder, okay, leaning against the wall like this, okay. Then obviously, because it leans against the wall, okay, here, we said that anybody in contact with the surface will have the normal reaction force, okay, acting as normal, that's perpendicular to the contact surface, okay. So this normal reaction, okay, for this, that over there, and of course there will be a component of the weight of this ladder here, okay, a component of the weight, but of course the entire weight of the object will act from where? From the center of gravity, okay. Then again, we have the normal reaction here acting 90 degrees, okay. Then in the presence of, when we begin to work with friction, which is our topic for today, okay, we'll also realize that other forces will come into play, which will be our frictional forces, okay, at the various, okay, points, okay. Then as we go on and on, we'll also be looking at moments. Then we'll come back to this system and then try to see how to get what? A moment about a certain point. Okay, so moving on, I think I saw a chart. Yeah, so if M1 is greater than M2, then you resolve them accordingly. I'm just introducing you to the topic and I'm showing you how to do the resolution. So if in the case of the simple pendulum, okay, in the case of the simple pendulum, if M1 is bigger than, the whole thing just changes. So it means like that your bigger side becomes what? M1, okay? So you just look at it. Then in the case of this object here, okay, if M2 is bigger than what? M1, then obviously there will be no motion, okay? So you just apply intuition to it. And then in this case too, when this object is bigger than this one, this guy here, then obviously motion is likely to be what? Down here, not so. So acceleration here is going to be what? Positive. And then this acceleration is going to be what? Negative. You understand? So it's just, so that is for Daniel. Then Eric said, does it mean R doesn't have any effect on the motion? Yes. It doesn't have any effect on the motion because the entire motion, especially on the left side, okay, this side, we are just moving, either we are moving forward or we are moving backward. We are not going up or down. If we were going up and down, that is where R and weight will have, okay, a part to play on the motion. But on the right side, you can see that what? Tension and weight are having a part to play because motion is up and down, okay, on the right side. But on the left side, no. Okay. I think I've resolved all the questions. Okay, so let's move on. Is Bernice in class today? Is Bernice in class? See view. Okay. Yeah, let me just pick your attendance and check. Just a minute. Yeah. So I sent you your material for lectures 6 to 8. Okay. Finally, I added the 8 to it. So you take note of those materials as well. Okay. Yeah, Sammy, well noted. Yeah, so we have we are looking at friction. So far, the systems we looked at, we assumed that there was no friction in play. So we want to look at friction, and we are saying that friction is the force that opposes relative motion. Okay, so any force that will oppose relative motion is referred to as friction. Okay, or you can say it is a tendency of motion of two surfaces in contact. Okay, good. So anytime two surfaces come into contact, friction is generated, and we can have two types. We can have either dry friction or fluid friction. Okay, under fluid friction, we have friction between lubricated surfaces, skin surfaces, internal friction within objects. Okay, and then for dry friction, we can have static friction. Okay, that's friction for objects which are static, which are just about to move, and then dynamic friction for objects which are already in motion. Okay, and our focus in class will be on on dry friction. Okay, good. So what then is dry friction? We are saying friction which resists relative motion of two surfaces in solid surfaces. Let me put it that way: solid surfaces in contact. Okay, now when a body is just slides or is about to move over a horizontal surface without accelerating, so just on the verge of moving, the body is static but just on the verge of moving. Okay, good. The applied force, the force that is being caused or being applied to move the object, is always balanced out by the frictional force. Okay, so just before you begin to move, the force or the force that will cause the motion, okay, will be balanced out or will be equal towards the frictional force. In other words, you need enough force to overcome the frictional force before you start moving. Let me put it that way. Okay, so just before you move in a static motion, the force required to cause the object to move must balance outward the frictional force. Okay, and another thing we have to know is the frictional force will always oppose motion. So if the force is acting to the right, like you are seeing here, frictional force will act to the left. Okay, so you always take note of that. Okay, so moving on, I have, the first law of friction says frictional force is independent of of area. Okay, that's the first thing you have to note. Frictional force is independent of the area. Okay, so the force generated, the frictional force, or the force needed to drag this body just before it moves, is the same force you need to also drag this body. So you need 20 newtons in each case to cause the object to move. But because the surfaces or the surface area were different, okay, it doesn't really means that the force is independent of the area. Then the second law says applied force is directly proportional to what? The normal reaction force. Okay. So the normal reaction rather relates to the force what applied. So in other words, if we're writing it mathematically, that would be what? Force applied is what? Proportional to what? The normal reaction, either N or you can put R. Okay. So in our context, we'll be using R. Okay. Then if we are to write it, okay, as an equation, that is going to be what? F is equals to mu R, where mu is the coefficient of what? Of friction. And what we have to know is mu is not constant. It depends on the materials in what? In contact. Okay. So we take note of that. Then having noted the the laws of friction, we want to take an example on its application. I think I saw a chart, but because I was just delivering okay, it's not a question, it's just a point. Yeah, so he says a block of mass 50 kg rests on a horizontal surface. Calculate the horizontal force needed to make it just slide if the coefficient of friction is what? Is 0.32. Take G to be 9.81. Okay, so in the solution, this is what we have: the block of mass 50 kg. Okay, the force applied F, normal reaction R, weight will be down. Okay, then frictional force will go to the left hand. Okay, then we have the parameters given. Mass is 50 kg. Of course, mu has been provided. Mu was provided as what? 0. Let me just throw some more light. Mu was 0 point what? 0.32. Okay, very good. Now we are saying that just before this body begins to move, okay, the force must balance out what? The frictional force. Okay. So we also know earlier that the force applied is proportional to what? The force applied, let me use a white marker. So the force applied, okay, is directly proportional to R, which is mu R. So, and we know mu. So the question is, how do you get your R? Okay, that is also very easy to obtain. We know from this motion that in the vertical direction, okay, so if you are looking at y components, okay, this body is not moving. There is no motion up, neither is there a motion what? Down. Okay, so the body is not accelerating. Acceleration is equal to what? 0. You understand? Which means that your normal reaction is equal to the weight. Okay, they balance out. So if you like, you can write R minus W is equal to 0. In other words, you are applying Newton's second law of motion. So the forces in the vertical component, which is R, okay, R here is positive, and then W is negative. So when you add them, that will be R minus W is equal to 0. Okay, good. Which implies that R is equals to what? Is equals to your W. Okay, but we all know that W is M1 is mg. Okay, W is mg. So, and W is mg. Mass has been given as 50. Okay, weight has been given as what? 9.81. Okay, 9.81. So once you do the computation like you are seeing up there, okay, that will give you 490.5. I hope you have your calculators with you. Yeah, so once you get your 490.5, this will give us what? 0.32. Let me use the white marker. So we have, oh, it's even been computed here, so no need. So R is what? 0.32, and then, sorry, mu is 0.32, and then R is 490.5. So when you multiply, you should get 156.96. Okay. Yeah, so let's continue. So that is for the first, okay, question. This is under static what? Friction. Now let's go to the next question. Yeah, so we have another question here. It says, calculate the force acting 30 degrees that will make the block slide as shown in the diagram below. Okay, so we examine the diagram carefully. Okay, this is the F we are being asked. Okay, it says calculate that force, right, which will make this object begin to slide. Now, let's resolve it carefully and then see the outcome. Okay, so when we look at this, okay, these are objects. Initially, yeah, we're given 400 Newton. Mu was given as 0.25. So let's write that somewhere. We have to take note of that. So mu is 0.25. 0.25. Okay, so let's go to the next slide. Yeah, so we have our force acting at 30 degrees. That too we know. The force was acting at what? 30 degrees. This is 30 degrees here. Okay, good. And then mu is being given as what? Mu is 0.25. 0.25. So what you do first is, because the force is inclined, it's like you are taller than this object, right? And then you have it inclined at your back and you are dragging it along. And that is the scenario. But you are not dragging this body, you're only dragging it in the horizontal direction for it to move. But you know, because the force is inclined, there is a vertical component of the force and a horizontal, which means you have to resolve the force. Okay, so in resolving the force, you're going to get the y component to be f sine theta, s component is what? F cos theta. Okay, and like I always say, try and resolve your system, okay, into the x and the y so that you can write your equations using the second law of motion. Now, because this body, we are still on static friction, because this body has not moved yet, okay, it has not moved yet, it means that the forces in the vertical will balance out, net acceleration will be what? 0. And then at the same time too, the forces in the horizontal will also be equal to what? The net acceleration on the horizontal motion will also be equal to what? 0. Okay, good. So we can have the equation first. Let's have the x. So we have x component. So that will give us what? F component, S component. What we have? We have F cos what? F cos theta, and then take into consideration the direction. Okay, F cos theta is positive. Because of the direction, it's going what? To the right. Take note of that. Then the next horizontal force is what? Your frictional force, which is negative what? Mu r. Is negative because it's moving to the left. Okay, like we said, the body has not moved yet. It is just about to slide. So acceleration is what? 0, which means your MA on the system will be what? Equal to what? 0. Then in the Y we have these vectors. We have R, which is positive because it's up. We have F sine theta, which is also positive because it's also up. Then finally you have weights. weight is 400 Newton. Let me write weight is equals to what? 0, because the body is still not moving. It's in a state of what? Equilibrium. So then we can input our values. This is where you come in with your calculator. So please get your calculators. If you don't have it, I will just go straight to my final answer. So we have the equations that will give us F, okay, cos 30 minus what? Minus 0.25 R, okay, is equals to 0. And then we also have R here, okay, plus what? R plus F sine what? F sine theta, F sine 30, sorry. F sine 30. I'm moving W to the other side of the equation, so that will be equal to 400, okay, Newton. So which suggests to us that we have two equations with two unknowns, okay. Once we have two equations with two unknowns, we can easily find what? The force, okay, either by substitution or by elimination. So you can easily make R the subject in this equation here, which will be 400 minus what? 400 minus F sine 30. So kindly do the calculation at your end. I have the final results here. I already display it. This will be 400, okay, minus F sine 30, sine 30. Then you substitute it in here, okay, which will help you to get your force, which was required of you. Okay, so let me clear the screen. I'm going to clear the screen if you haven't written the equations. Okay, so I got my solution on the screen. I want to clear that page. Yeah, so once you've estimated all that, okay, like I showed you, if you do all those calculations and you do the substitution, then you come down and your force is going to be what? 100.9 Newton. So that will be the force you require to make the body just begin to what? To slide in a static, okay, friction motion. Yeah, so we'll take, let me take one or two questions before I move to dynamic friction. Any question? Any question? Any question? Okay, I think we're okay. So we want to move on. Okay, so we come back to this same question. We are not there yet. I'll skip it for now. Later we'll come back to it. This is another example on static friction. But finally, here we asked to find, I think, the force required. Okay, the force required. So I will post this as an assignment for you. Okay, so that you try your hand on it. You're supposed to find the force required to push this object in the horizontal, okay, direction. Okay, so next we have a question on dynamic friction or kinetic word friction. Okay, and this time when we talk about kinetic friction, we mean dynamic friction. We mean friction, okay, which occurs between two solid surfaces in what? In motion. Okay, so we have an example. It says a force of 400 Newton pushes on a load 25 kg load, okay, at an angle 50 degrees to the horizontal. The load achieved a velocity of 2 meters per second in 4 seconds, okay, from rest. So it means initially the body was at rest. We pushed it with a force of 400 Newton at an angle of 25 degrees, and then it achieved a velocity of 2 meters per second in 4 seconds, starting from rest. Determine the coefficient of sliding friction between the load and the floor if the load is placed on the horizontal plane. Okay, so let's see. No, this is not captured here. Let's give it a try. So just a minute, let me just log off. Okay, so let's so I want to move this away. Yeah, so this is what we have. Now for the sake of illustration, I've minimized my writings. So this is what we have. We are told that an object, okay, okay, yeah, very well. Yeah, so that's our surface. Let me just keep it simple. And then we have the force, okay, pushing. It's pushing. What's happening to the mouse? So we have the force. Okay, the force is pushing, okay, at an angle which is 50 degrees here. So the angle here is what? Theta is what? 50 degrees. Okay, that's our force. So we have 50 degrees here for the angle. The force has been given as what? 400 Newton is well noted. So F is 400 Newton. Okay. Then what again were we told? So this object moved from rest. Okay. What's the mass? This object is 25 kg. Which will come here, which will be what? Mg. That will be the weight. We have the normal reaction. Okay. Then this body after 4 seconds, the velocity was what? So which means that V naught, let me put it here, V naught is equal to what? Initial velocity is 0. Okay. The final or the velocity at 4 seconds is what? Is 2 meters per second. 2 meters per second. Then we have the time, or the change in time is what? Elapsed time is 4 seconds. Okay. And because this body is moving from rest and has attained velocity, it means we have acceleration in there. Okay. Good. And to find acceleration, we all know which equation to use. We know that is Vt is equals to V naught. Okay. Plus what? Plus At. Okay. So it means that T is equals to what? T is equals to Vt okay, minus what? V naught. Oh, A, sorry, is equals to Vt minus A, V naught over what? T, okay, which will be equal to 2, 2 minus 0 over 4, which is what? Which is 0.5 meters per second, okay? That is 1 over 2, so 0.5 meters per second. And once again, as you're aware, after